Hey all, Mr. P here, and we are here to start Unit 6, Similar Triangles. Our first concept is going to talk about similar polygons in general, and then we'll get into similar triangles specifically. Remember that a triangle is the smallest polygon we can have with 3 sides, so anything that we know about similar polygons will apply to similar triangles. So if 2 polygons are similar, then we know 2 things. First things first, this symbol right here, this sort of squiggly symbol, it looks like the top of the congruent symbol. That is our symbol for similar. So if we want to say that things are similar and we want to show that, we can use this symbol, just like we've used the congruent symbol. So if we know 2 polygons are similar, then the first thing we know is that their corresponding angles are congruent. And I underline congruent because things can get a little tricky here talking similar and congruent. The angles will be congruent, and I put the symbol there as a reminder. We also know that if 2 polygons are similar, then we know that there's this relationship between the corresponding sides, where if we write a ratio of those corresponding sides, for each pair of corresponding sides, they'll be in proportion, and that means they'll have equal ratios. So in congruent polygons, or specifically congruent triangles that we talked about, the corresponding sides are congruent. In this case, we're going to write ratios of the corresponding sides, and those ratios will be equal, which is what it means to be in proportion. So let me show you an example of that. Hopefully it'll bring you back to last year and you can remember ratios and proportions. So if I want to determine if these 2 rectangles are similar, I need to first check the angles. I need all the corresponding angles to be congruent. And it just so happens, if you notice, all the angles in both of the rectangles are right angles. So we know that all the corresponding angles are congruent. So I'm just going to put a check. We can move on. If they weren't all congruent, then we could stop and say that these 2 rectangles are not similar. So now we need to look at the ratio of all of the corresponding sides. In this rectangle, I have 2 10-unit sides and 2 14-unit sides. Here I have 2 15-unit sides and 2 21-unit sides. So the 14 and the 21 will match up because they're the longer ones, and the 15 and the 10s will match up because they are the shorter ones. So if we choose those 2 corresponding sides, we can write a ratio, which is just one measure over the other. It's a fraction. We call it a ratio because it's comparing 2 measures. We can write the ratio of those 2 sides. And we can keep going. And I'm writing the ratio from the smaller one to the bigger one. So the smaller one on top, the bigger one on the bottom. You don't have to do it that way. You can write the bigger one on top, the smaller one on the bottom. Just make sure that you're consistent as you go. So now I want to simplify all of these ratios to see if they're equal. If they're equal, then that means they're in proportion and we have 2 similar rectangles. So 10 over 15 reduces to 2 over 3. 14 over 21 also reduces to 2 over 3. And I think you might notice right away that these will all simplify to 2 over 3. So all of the ratios of corresponding sides, I have 4 pairs of corresponding sides. I wrote the ratios of their lengths. I simplified them. They all simplify to be the same thing, 2 over 3. We can check these are similar rectangles. So that's what it means to be similar. Let's look at a different type of example. Here we're not given all the angles, we're given something different, and you'll see this throughout. I have parallel lines. That's what these arrows mean. Again here, parallel lines. Same thing over here. So I need to figure out first all the angles in these quadrilaterals. So I have parallel lines and a transversal. I know that these 2 angles are supplementary, so this one must be 100. Therefore, this one is 80, and this one is 100. If you have questions about how I got this, we'll discuss that further in class. It's going back to the parallel lines unit. Same thing over here. These two are interior, same side interior. So this one is 80. Same side interior. This is 100. And this is 80. So I have pairs of corresponding angles. I have two pairs of 80-degree angles and two pairs of 100-degree angles. So I could say that I have some corresponding angles. Now let's look at the sides. The longer sides over here are 6. The longer sides over here are 24. So I'll write those two ratios. And obviously we know those will be the same. We'll go from the shorter sides over here, 5, to the shorter sides over here, 16. And now we want to see if these simplify to be the same. So the 6 over 24 simplify to be 1 over 4. And we can't really simplify 5 over 16. It doesn't simplify to 1 over 4. So even though we have two pairs of equal ratios, they're not all equal. Therefore, even though these two polygons kind of look similar, they look pretty close, they have congruent angles, they are not similar because the ratios are not in proportion. Go ahead and pause here and practice what you just learned. Determine if each pair of polygons are similar or not. Remember to start with the angles and then go to the sides. So in this first example, I can see I have those two angles correspond and are congruent. Same thing there. This angle and this angle are congruent. Those two angles are congruent. Remember your symbols. So my angles are good. Let's check the sides. That's usually what makes or breaks this thing. These two trapezoids have bases. The smaller base is 8. The smaller base here is 10. And I like to go from small to big. You don't always have to, though. The bigger base in the small trapezoid is 14 over 21. And then we have 9.1 over 16.7 and 9.1 over 16.7. So we need to make sure all of these ratios simplify to be the same thing, or else the polygons are not similar. 8 over 10 is the same as 4 over 5. 14 over 21 is the same as 2 over 3. And we can already stop right there. These are not equal. So no matter what happens with the 9.1s over 16.7, these are not similar. Let's look at this one over here. I have to go around and figure out the angles. This one is 40. And we have parallel lines again, so we can go through and find that that angle is 140. This one is also 40. 140. I have an angle here that's 130, so this one is 50. And I can stop right away. I know I'm not going to have angle pairs, corresponding angle pairs that are congruent, because I have 130 and 50. I have 140 and 40. These are also not similar. Another way we can use knowing similar polygons is by finding a missing side. So in this example, I know that these polygons are similar. I'm given that they're similar. Given, that's a word we used in proof the other day. So what I need to find is the scale factor. The scale factor is the ratio of corresponding sides. So if these two polygons are similar, which I told you they are, then the ratio of the corresponding sides will be the same. They'll simplify to be the same fraction. That fraction is called the scale factor. So if we find the scale factor, we can write a proportion and solve it for the missing side. So So let's do that. 10 is going to go over 15, the two shorter sides. And I can find that my scale factor is 2 over 3. So that means if I write a ratio of these two corresponding sides, question mark over 24, it should be equal to my scale factor. This is a proportion. They're two equal ratios. In order for these two polygons to be similar, then question mark over 24 needs to equal 2 over 3. So we will solve this proportion by cross multiplying. 3 times question mark and 2 times 24. Then we can divide both sides by 3 and get question mark is 16. So our missing side is 16. So this is how we can use similar polygons to find a missing side length. Here's another example of how you'll see that. We have two polygons. I'm telling you they're similar. And the scale factor from A to B is 2 to 7. So this is the same as writing a fraction 2 over 7. That's our scale factor. It goes from A to B. So that means the side from A has to be on top. The side from B that corresponds is on the bottom. Now we have a proportion that we can solve. 2 times question mark equals 6 times 7. Divide both sides by 2. And this side must be 21. Go ahead and pause here. I'm telling you that each pair of polygons is similar. Find the scale factor in the first one to find question mark, and use the scale factor in the second one to find question mark. Here it looks like 10 is the shortest side, and it looks like question mark is also the shortest side in the littler rhombus. So our scale factor is going to be found by putting 6 over 12. You could have done 12 over 6. You'll get the same answer. But again, I like to put the smaller one on top. This reduces to 1 over 2. So this is my scale factor. So that means question mark, from the smaller polygon, over 10 needs to be equal to 1/2. We'll cross multiply. 2 times question mark equals 1 times 10. Divide by 2, and we can find that our missing side is 5. Over here, we know our scale factor is 5 to 6, so from A to B. So that means question mark over 30 should be equal to 5 over 6. Cross multiply. 6 times question mark equals 5 times 30. Divide both sides by 6. You should get that question mark is 25. And I'm having a little bit of an error here, so it won't let me write, but you should get question mark is 25. Luckily, we're to the end here, so try these two problems, and we will discuss them at the beginning of class. Again, if you have questions about ratios, proportions, or finding angles, knowing that sides are parallel, make sure you bring those questions to class, and we can talk about them together or one-on-one.